bulldozer. Now, I'm not sure whether I'll be able to draw that or not, but let me just try drawing maybe a truck or something like that. And you can see that it's recognizing that as a truck. Now, maybe I should have so it told that that's a fire truck. So I wasn't able to draw it correctly, but nonetheless, let's do the next task, which is to draw a donut. And this time, I'm pretty sure I'll be able to draw a good enough donut and see. It has recognized it as donut. The 4 out of the 6 drawing is a sea turtle. Again, not so easy one, but let me try my best to draw a turtle. Next, something like this, and a small little tail, an eye, and a water. So yeah, it was able to recognize it was a sea turtle. And the last one, the second last is lightning. Okay, so I don't know, should I draw a bulb which has some rays coming out of it, or maybe a thunder? So in 20 seconds, it wasn't able to recognize it. And now the last one, rain. Okay, so let me just draw a cloud, one here, and some, yeah, so it did recognize it as rain once. Now it's saying this is aunt. Oh, it wasn't even able to recognize the rain, which I thought I drew correctly, but no worries. So now, what I just did is I tried to play with a machine which was trained using a neural network. A neural network designed for a specific task, which can classify your doodles. It is not a simple images which we see in our day-to-day basis. We, all of us, must have learned about or heard about a lot of image classification examples. Maybe it can be a face recognition system, something, a self-driving car, which would be viewing a real scenario, a real pathways, your roads, houses, trees. So it is not as similar to those images. These are doodles, and this exercise, this fun game is being developed by Google, which is known as Quick Draw. And here it gave me like 6 examples which I had to draw, and a neural network was supposed to guess. Now, it wasn't able to recognize the rain. So let me just click on that and see how. Okay, so it was a train and not rain. Okay, then lightning. Let's see on which kind of images this neural network has been trained. So these are some of the lightnings which are used for training data, and the donut. This one is which I draw, and this is what other people has drawn before me to teach this neural network how a donut should look alike. So I hope you can go through this website and check out this experiment by yourself. Play with the neural network to get the feel of how image classification works. More on that, to give you a feel of this field, to make you excited about deep learning. Here is one more experiments with Google, specifically designed for AI, where you can get a lot of different examples, such as how to visualize a larger space, what a neural network sees beforehand. So by end of the session, I'm pretty sure all of you would be have knowledge of how to train a neural network, what is neural network, what is convolution neural network, and how to visualize that, how to tweak the parameters, etc. So these are all different kind of an experiments, and one of my favorite is semiconductor. So if you have ever known about pose estimation. So here what we did, we draw some images and make a machine understand that what that doodle was. Now there are other experiments as well which can understand what pose you are making right now. So here, if you can see my screen, I'm making like a 5. Here I'm doing a yo sign or maybe a thumbs up sign. So these are just my hand gestures. But when the whole body movement is done, when you are shaking your hands here and there, when you are dancing, you can also teach a machine, a robot, to dance, to move steps like you do. So this is an application of a pose estimation. Then you would be person, just like this in an empty room. You would be just shaking your hands here and there, but then just for a minute, see, I want all of you to understand what Okay, so all of you are now requested to chat in the chat box that what you understand from this video. Okay, so in Zoom, um, can you all please write what you learned from this video, what this video is actually doing? Maybe a couple of you. Okay, so Neha is saying that it recognizes the hand gestures and accordingly makes music. Cool. And Mayuri is saying that catch your gestures and act like the same. Yeah, so Mayuri, it wasn't exactly catching the actions, but as Neha mentioned that it is learning from our body motions, and then it has some predefined small tunes that if a hand is something like that, make a tune higher, volume higher, a bass higher, and if it's moving, a waving kind of thing, then play maybe saregamapa or a low bass and a low volume. So here, thanks a lot Neha, Mayuri, and Kunal for participating. And yes, you understood very correctly that what this neural network and what this application was doing. And now I have one last demo for all of you to see today. And that one is a teachable machine. So I guess most of you have in some or other social media have seen that after the COVID situation, there are a lot of people who are building a face recognition model, but not exactly your face, but whether a person has wear a mask or not, right? So I am now going to implement that same model in less than 2 minutes. Okay, so it's 5:14 right now in my system, and what I'm gonna do is first of all create my training data set, then train the model, and then also test the model. And then all of you can reuse that model in whatever application you have in just 2 minutes, in less than 2 minutes maybe. So first of all, it's 5:15. I'm on the site, and there will be two classes. One would be uh, with mask, and the other would be without mask. Okay, so Now, what I'll be doing is creating some of the images where I am wearing mask, and I'll make my machine understand that this is how my face looks like when I am wearing a mask. So I'm turning off the webcam, and here you can see that I have wear N95 mask, and now I am just creating some of the images where I have weird masks. So there are like 77 images has been captured. So that's the class one. And I want my machine to learn to understand from this images how I look alike or how any person in general looks alike with a mask. And now I'm again gonna get some images of where how I look without mask. So here I'm just speaking and capturing some of the images, and like in a second it has captured 77 images, and here all of these images. If you don't want some, you can also delete some of them. It's up to you. And here in a second we now have 77 images of me wearing mask and some me without wearing a mask. And now the next task is to teach this machine, teach this model of how to make that understand the difference between these two classes. And here, by end of this session, all of this fancy terms like epochs, batch size, learning rate, you would be able to understand. For now, just ignore these terms, what they are. Just understand that this is a black box where I gave a few images with mask, few images without mask. I trained that model for 50 iterations, and here it's the preview of the test of the testing environment. And here you can see that this is the test image it is capturing right now, and it is predicting 100% with surety of 100% that this image, this me in the screen, is not wearing a mask. Now let me just put this mask on my face, and you can see that it's changed this accuracy to 100% with mask. Now let me just shift that mask a bit. And now you can see that the model is shaking here and there. Now it is not able to pretty sure understand that whether I have weared a mask or not. Let me wear that again. It's 100% sure this time that I'm wearing a mask, without mask, with mask. So it's shaking, but still the accuracy of without mask is like around 93, okay, more than 90%. So if even if I have this mask in my image, the neural network which I have trained is pretty sure that whether I'm wearing a mask or not wearing the mask. So yeah, it's 5:18, and I was just explaining you, but this is how you can train. And when you press on the export model, it gives you the URL and the code itself, so that you can deploy this code, this model on your web browser, and anyone in the world can play with it. I'm not going to go with this deployment stuff right now, which you can explore by your own. But yeah, this is how you can have an image project, an audio project, a post estimation as well. Here, if you have a number of songs of maybe Arijit or Neha Kakkar, whatever best singer you know or your favorite singers are, you can play those audios, and you can record their voices, and then whatever the test song which you play, your model will predict that who the singer is, and so on. So let me know in the chat box that whether you enjoyed this different experiments, and whether now do you want to understand more that how this applications has been made, the quick draw, how a neural network would learn to understand doodles. The next experiment was to learn the poses and then to generate music out of it. And the third one, which I showed you, was image model, which I just built in less than 2 minutes to classify that whether I was wearing mask or not. So yeah, I'm happy to So hand gesture live tracing is done using neural network. Rajat, yes, to answer your question, yes, it was built using neural network, and I'm happy to understand that all of you have enjoyed all of these experiments. I have put all the links in my deck, which I'll be sharing with the organizers by end of this session, so all of you can go through these links by your own and understand in depth. So starting with, let's dive into deep learning with TensorFlow. Welcome all of you again. In this session, we will be going through a little bit of theory and also uh, not just theory, but we will implement all of this stuff using code. So very initially, I just showed you some of the demos, but how this demos work behind the scene, I have written a lot of code for you guys, which we will be going through during this session and also the theory part of it. Oops, sorry. Okay, perfect. So let's start then. Deep learning, artificial intelligence, machine learning, and a lot of fancy terms we have been listening since maybe past 2 or 3 years, and it has become like a hype. But whether this is a hype or reality, so we just now show a lot of different demos, and it seems like it is has become a reality now. And there are researchers and developers around the world who are pushing their boundaries to make their dreams into reality, make the self-driving cars into a reality. We are moving towards those dreams step by step, one step at a time. Starting from a face recognition model deployed in your smartphones, which can unlock your phone, to the self-driving car. It seems like deep learning and artificial intelligence have the advancement very recently, but that's not quite true. This field is around us since like 1950s or early 1940s, when first of all IBM developed a system, a machine. They taught machine to play a game Go, similar to you might have seen it has a checker box kind of a interface, and then it has white and black colored bits or and that machine won in front of the world's most advanced and best player in a Go. So that machine was able to beat the AlphaGo champion. So since then, since 1950s, all of this thing has was been there. But why it's a hype and currently? Because the data which we have right now, all of us are the posting our feeds on social media. There are billions of hours of videos already on YouTube and are being uploaded every hour in G- GBs and terabytes and petabytes. There are a humongous amount of text data, images data, unstructured data out there. So the amount of data we have right now, plus the amount of computation power we have, you must have known Moore's law. So every 24 months, the amount of transistor put it into a unit amount of area is being doubled every 24 months. So the amount of computation power we had in 1950s versus we have today. Today we do not have just CPUs, but we train our models on graphical processing units and tensor processing units, TPUs. And the research work was being done in 1950s versus being done today using open source platforms such as GitHub and some of the projects which I showed you. All of them are making their codes open source so that me and you, the person like us, can explore that, make advancement on that, and can learn from that. So due to the data, due to computation power, and due to the open source community we have around us. It has become a hype in a very recent year, but it has been since 1950s or 60s around us. So artificial intelligence, machine learning, and deep learning has been used very interchangeably by users. But there are a very thin line between all of these three different fields. And here I would just like you to understand what is the difference between these three fields, and then we'll quickly go to how deep learning and neural networks work. So artificial intelligence is to make machines, computers behave the way we human behave. We want them to be take analytical decisions. We want to make to them replace our job, the manual job which we as a human do, whether it's driving a car or writing a code or just do image classification, writing a poetry, or maybe doing comprehension of a passage. All of this task which we currently only humans can do, if we want machines to do by themselves, it's known as a field of AI, which has a subfield called as machine learning, which is nothing different than a linear algebra or statistics we have learned in our schools and universities. So it works purely on mathematics and using the models of reg- uh, regression, classification, etc. Here is just an image of a spam versus not spam. All of us will be are using Gmail, right? So in Gmail, you can find a spam folder. And it's like not all of us would be putting our emails to that spam folder, but Gmail has a pre-trained model trained which can classify whether any email you receive is a spam or not based on some of the text word like congratulations, you have won 1 billion rupees, or you have won lottery, or when an email has a lot of emojis inside it or a lot of special characters. So those are different features via which a model can learn that whether this an email is a spam or not. And the third field, which is a part of subfield of ML, is deep learning, which does similar task of classification, understanding the images, understanding the text, but it works using neural networks. So the way we, a human brain, learns and understand, we have tried to make machines learn via that field. And um, they in this slide I'll be using a lot of terminologies like features, labels, examples, labeled examples, and so on. So I gave you an example of spam email filtering. When you have a word like you have won the $1 billion lottery, or there are a lot of emojis, or there are a lot of fancy or special characters, all of those are known as features. Feature to make an email a spam versus feature to make an email a non-spam. The label. Do you remember I edited the class 1 and class 2 when I made this image model? Here it was having class 1. What's the name of the class 1? What's the label? What are all of these images are known as? So whether it's a cat, all images of cat versus dog. So those are known as labels. And then I gave examples, images to my model, and then I trained the model. And here there can be two different models. One is the classification and the other is a regression. So here the task of this model was to identify whether an image is with mask or without mask. So this is like separation in just two different classes, which is known as classification. Versus when you predict, when you build a model that given the data of last 3 years of temperature in, let's say, Delhi, what would be the temperature tomorrow? Or given the stock price data of, let's say, Google's or Apple's stock, and what could be the stock price in the next week. So those kind of problems are fall into the category of regression when given the data you want to predict the future values or the values which aren't there in the data, versus a classification model where you just want to classify between two or more than two classes. So in machine learning, what you have to give as an input is label data. Also, so that means what class that represent and what are the input images. Then there is a whole machine learning algorithm working behind the scene, and then you can get the predictions. There are three different kinds of ML algorithms known as supervised learning, unsupervised, and reinforcement learning. In supervised learning, it's like you are sitting in a class and there's a teacher which just teaches you. So there is a teacher which is supervising you that whether an email is a spam or not. So in supervised learning, with images, you are given labeled example as well. Worse, and in unsupervised learning, it is like a self-learning, learning without a teacher. So right now I'm detecting some things, I have some slides prepared, and all of you are listening to me. So it is becoming a supervised learning. You are right now for this moment learning what are the different approaches of ML under my supervision. But when you would be learning by some web searches, by watching some videos, or let's say reading some blogs, you are learning by yourself. It is known as unsupervised learning. When you do not have an explicit label given as input, or when you do not have any explicit model to make you understand that whether this image is of a cat or dog. It's like you just throw 1000 images of all the fruits present in this world, and then you make your machine to understand that whether this image is of apple or whether it's a grape or a banana, etc. So given all of the images without label is known as unsupervised. Given all of the images with their labels is known as supervised. And then there is a third field which works through a feedback. So when I made you see all of the demos, and then I asked you to write in the chat box that whether you enjoyed this stuff or not. And when three or four of you when wrote that yes, you like the examples, it gave me positive feedback. It boosted up my confidence that yeah, whatever I showed to you guys, you were able to grasp, you were able to understand. So it gave me positive reinforcement. Similarly, when the machine is predicting something and when we gave that machine a positive score when it has identified some true classes, so that is versus when giving some negative examples, some negative rewards to your machine when it is not predicting something good. So giving like positive versus negative scores to your model is via an agent in the environment that's known as RL. We are not gonna go in any of this detail in this session, but let's say go deep into deep learning. So what that is, a formal definition. It utilizes learning algorithms. It mimics the neural networks. It has some hierarchical learning. It's a part of machine learning. Okay. Let's not go into this detail, but understand via some of the graphs and some of the easier explanations. So let's say, let me first make you guys understand this thing. So then I'll go back to the other slides, which I have skipped, but okay, so you want to classify these points. There are some red points out there and there are some blue points out there. And there's one line which separates these two data points. Whatever to the left of this lines is the class blue, and whatever is the right side of this line is class red. So this is how we can classify these two data points. And now, if we have a data points like this, when So we cannot have one line which can separate these two classes. If I draw a vertical line like this, then the left, uh, all the data points to the left of these lines are not of a same class. There are some blues and there are some whites as well. So if I draw a horizontal line, even not all the classes are to the same side. So what should I do? Should I draw two lines? So whatever in this region is a class white, and after intersection of these two lines, whatever is this in the top left corner is blue, whatever in the bottom right corner is a blue, versus whatever in the top right and bottom left corner are whites. So here I had to draw two lines. Here I just had to draw one line. Okay, but when imagine you have these data sets and now you want to draw some lines or some shapes via which you can separate all of these blue points and all of these orange points into two different classes. It is just not possible to draw any lines, any shapes which can classify these orange and blue dots of this data set. That's why it is known as a non-linear task. There aren't any linear lines which you can use, and it is one of the examples of complex data set. So how to work on these data sets? And neural network are one of the best approaches to work on non-linear data sets, a non-structured data set. So um, this is an example of how our neuron inside our brain looks alike and works alike. So there are some nucleus which gets some input data using this dendrites. I'm not going into a biological discussion right now, but just give you a really very brief what is the input and what is the output of this neuron. So there are some dendrites which get some input, and then inside this body it understands the voices, it understand the images, it understand the text, and then through this axons it output. This passes the information to other neurons and to our body. We will do the same thing to our machines. We will give it some input, we will expect some output. We will give input of me with a mask. I expect that machine understand that it's a mask. And then we will have whatever the thing is done in this blue region, we will make our machines do with the help of hidden layers, some other neurons, some other mathematical functions which can be implemented to understand the parts of an image. So let's say there is a 3x3 matrix like this, and how you will give this as an input. Imagine this is me wearing a mask. How I give this as an input to my machine. So I will flatten out my this image. I will this 110 is here, and then the second row 421 is here. So this 3x3 matrix has been stacked on each of the each on each of them. So all this 3x3 matrix is now being 1x9 just a vector, and that would be my input. So all of this blue dots here it has shown as like 3, but when I use this matrix and input, it'll be a 9 neuron input to my model, and then I want my model to understand that what this output was, and how it understand, how it learns is via sticking up more and more hidden layers. So we added hidden layer as shown in the yellow color. It will have some weights and some biases. So now in my image, I want my model to understand how my eyes look like, how my nose look like, but I don't want my model to really make attention to what is the background, what is the person sitting next to them look alike. So I want my model to pay attention to some of the region versus do not pay attention to other region. So, in other words, in the fancy term of ML or DL, I want my machine to give more weightage to the features which are important to classify a particular image. And um, that way, I will uh, give you more detail that so we understand that this is a non-linear example. To separate these classes, we will be using some mathematical equations. We will be using, let's say, the weights of these neurons are 1, 2, and let's say -5 or -100. What does that mean is, do not pay attention to this thing, which is not at all important. We are giving it negative weights versus this are some important stuff. But still, we are just making some mathematical functions. We are adding the weights of these three layers and giving the output. So this is still a linear function. We are not introducing any non-linearity so that it can understand complex features. And for that, we will be using some activation function. But before going into depth of how activation function is, let me just go to the code and whatever we have learned so far, to give them input, to flatten out the images, and then to stack layers on each of other. These are the first three steps to build any model, which I have written here and will be understanding next. So I'm using Google's collaboratory mm, uh, right now, and I'll be sharing the link of this code with you all also. So I'm just running this code snippet right now where I'm importing TensorFlow, which is an library to develop ML and DL models. There are tens of other libraries like PyTorch, Caffe, Theano, CNTK, and a lot. So here I am just using one of them and using a data which is known as MNIST dataset. So there are some handwritten images of 0 to 9, and here I'm showing you how this images looks like. So I'm giving these images to my model as input. So how of these are all the digits from 0 to 9, and I have plotted here just 25 images, but the model actually has 60,000 images in their training data set and 10,000 images in their test data set. What does this mean, train and test? So the images in the demo, in the demo I created 77 images of myself wearing mask without wearing mask. Here I'm giving 60,000 images to my model of how these numbers are written, because you can see that here is a 6 written, here is also a 6 written, but they are quite different in a nature. So we want to cover all of the different cases of how are all the different cases of a digit. One can be written a slant like this, or a vertical line like this, etc. And then once the model has been learned from the 60,000 images, we want to test that whether it was able to learn or not. What is the accuracy? What's the prediction power? So for that, we will be using 10,000 images. I have just downloaded the data set using caras.dataset.ms, and then I loaded this data set and split it into two halves, one for training and one for testing. In training images is printed here. There are 60,000 images. All of them are of 28 cross 28 cross pixel size. And in test, there are also both of those has images and labels. And then moving ahead, um, creating layers. Okay, I mentioned that in the PPT that we will give input. So we have our input ready. We have our output also, the label. When I give this image to my model, I want my model to predict that this is 5 written or this is a 0. So that's what a label I want my model to predict. And now in just 5 to 6 lines of a code, we will write a model which can understand, which can learn from these images, and then can work on the real time and predict stuff for us. So for that, this is a simple syntax, keras dot sequential. First of all, I'm not at all coding any deep neural network, but I'm coding just a simple sequential model, which is taking an input of 28 cross 28 cross size images, and then it has just one final layer, which is a dense layer, and it has activation softmax. I'm pretty sure you guys won't understand what this thing is. So now let me go back to my slides to make you understand. So here we have downloaded the data set, we have split it into training and testing, and we have also, uh, you can say that all of these are grayscale images. What does that mean? The pixel values of these images are between 0 to 255. But then, if you think that something having a value 0, something having a value 10, and something having value 250, it is possible that a neural network learns that something having higher value means that feature is more important, versus something having less value, that means it is not that much of important. And that means that whether an pixel value is near to black, near to uh, 255 or 250, it is possible that our model learns in not a desired fashion. We don't want to give this wrong explanation to our model that a pixel having higher value means it is important, a pixel having lower value means it is less important. We don't want our model to learn this thing. That's why we are just normalizing, and we are squeezing all of the 0 to 255 values between 0 to 1. So this is the pre-processing stuff I have done on all of my images using just single line of a code. And then we will understand now what is this activation function and what is this 10 written over here. So for that, um, here I have a slide of a softmax. So what a softmax function does is, given an input, it has 10 output classes. There are images from 0 to 9. That means there are 10 classes. And now I want my model to give me a possibility, a probability that what is the uh, prediction of my this image is. So here it is saying that 0.3. Now converting into percentage, that means here the model is saying that I am 30% confident that this image is of 4, and it is like 22% sure this input image is 7. So converting all of these numbers which were here in the neural network to prediction, to give input in possibility in percentage, is what the last softmax layer does. So there in the code, if you remember, digit written 10 represent that a this is, I want answers in 10 classes. If we were using just mask versus not mask images, then they are just 2 classes. Here there are 10 classes, and then there are just a softmax function to convert all of this number into um, possibilities, into probability. And once we have uh, written this 3 lines of code that take this input and give me output in one of the 10 classes using a softmax function, we will compile our model. And now again, there are some fancy terms like Adam, suppress, categorical, cross entropy, and accuracy. Now I'll make you understand what this 3 lines is again. So I told you that we want our machines to learn. We human learn from experiences. Remember the days when you were riding the cycle for the first time, and there are possibilities that you fell on ground for a couple of times. Only after that you learn how to run a bicycle. You learn from your mistakes. You learn that how to make a balance on a bicycle or on a two-wheeler. Similarly, we will make our machines learn from the mistakes. We will give all of these images as an input. Then it will make some mathematical functions on top of it, and then it will predict that this is an image of a cat. But it is possible that it is not true. So now, since it wasn't true, it will implement an algorithm which is known as back propagation algorithm. And then we are giving input images which are labeled. So we are giving the zero and that label zero as well. So we are first of all, in the training phase, we are making our model understand that this is how zero looks alike, this is how one looks alike. Even if it is not able to understand, it has predicted that this is not zero, this is digit 8. But then it will use a backpropagation algorithm to learn from its own mistakes. So for that, it is written over here that what kind of optimizer you want to use, how your model up I'm sorry, how your model is updated based on the data and the loss function. So when you give an input as a cat and it predicts a dog, it's a loss. Your model is not predicting. So then we will make it understand using the optimization function that it's okay that you predicted something wrong, but in the next iteration, understand that that wasn't a dog, this was a cat. So this is a very beginner friendly lecture today, which we are doing. So I am not going to deep in what is exactly the function looks alike, what are critical cross entropy, how you measure the cross entropy. So deep learning is concept heavy but code easy field of artificial intelligence. Here you can see that this 3 lines, I define a model structure, and via this 3 lines, I will just compile and train my model. So in just 6 lines of a code, I will be training 70,000 images. I'll be using 70,000 images to build a 10 class classification model. It is easy to code, but it is difficult to understand. And then it is not at all easy to make you guys understand in an hour or two session that how all of this works behind the scene. But this is just an introductory session to give you the feel of how these things work and how that looks alike. So similar to Adam Optimizer, which works on a gradient descent algorithm, just give you a quick overview of that. So assume that. So I mentioned you that when your model predicts a dog instead of cat, now we want to make it understand, and we will be using gradient descent algorithm for that. So our goal is to reach to the bottom of this parabola. We are starting from here, and we want to reach here, which is the correct label, and we want to make the minimum amount of information loss, and we want to reach here as quickly as possible. So from the starting point, we will move here to here to here, step by step. We won't be very optimistic that our model will be learned in a single go in like a few seconds, but we will give it enough amount of time to understand from images to images step by step. So uh, this is something scary. Some partial derivatives are there. There's an alpha, which is a learning rate. So in how many amount of time you want this model to do? There are models out there which are trained for 3 months. 3 months of just training. After 3 months, you would, when you give an input your image, it will tell you that whether you have your mask or not. Will you be ever interested in building or working on those models? Possibly no. Versus a model which which is trained like just for 10 seconds. But then whenever you predict, whenever you give some test images predict wrong, it always gives you wrong output. So even that is not desirable. But if you want to give that model a specific amount of data, a specific amount of time, and then when you have like achieved 80 or 90% accuracy, you want that to go to production, to go live. So for that, it is up to you what learning rate to choose. So now going back to this advanced option again, there is epoch, there's a batch size, and there's a learning rate. So here you can see that the learning loss was set 0.001. What does that mean is, in this equation of gradient descent, theta is equal to theta minus alpha del by del theta of j. So this theta j is the next step of your neuron. This is your current state. And then you want to go from this dot to this dot. You are going to a negative direction. You have to subtract something. So that is what is here, the partial derivative. And alpha is a learning rate, which is a hyperparameter which you have to tune based on your models, based on your data set. A batch size, if you remember, we have currently in this MNIST dataset 60,000 images as an input. And in the code, I have written here um, that what for how many iterations I want my model to run. So there are 60,000 images. 10 epochs means every single image from this data set would be given to as an input to my model for 10 times. My model will see each of this individual images 10 times and it will learn from it. So that is what is known as batch size for, that is what is known as epoch, for how many times you want your machine to see every single images of your data. What batch means is, it is not always possible to give just one image to your machine as an input, then second image, then third image, and then 60,000 image. It is a very time consuming process. So to do some parallel processing work, it is also possible to give like 20 images in every step. So out of 60,000 images, let's say I want, on every iteration, I want to give my machine an input of 1000 images. So from 1000 images, it will learn in a one go. Then from all of the mistakes and prediction it has made, it will learn from its error, and then it will pick up another 1000 images, learn from it, then it'll pick up another 1000, and so on. So how many images you want your model to learn from in a one go, it is known as batch size. For how many iterations you want to iterate, that is known as epoch. And how faster you want to make your machines learn, it is known as learning rate. All of these are hyperparameters which you can tune according to your model and to your data set. So starting from here and predicting an output, and then coming back to this input via changing weights of this neuron is known as one epoch. So giving an input image, uh, your model predicted it as a cat, but really it was a dog. So now you will give error to each of this neuron. You will pass the error data to each of this neuron. So first of all, you started from bottom to top. Given an image, you tuned some weights and predicted the output. Now, when the output wasn't right, you calculated the error, propagated that error in this backward fashion, and then you come back to your input again. So when you complete this one cycle of going from input to output and then coming back to the first layer, it is known as one epoch. One cycle means one epoch. And um, since you are going in the forward fashion for the first time and then coming in the backward fashion in the next time, it is known as back propagation, the algorithm. And here I have given you a link of how exactly this back propagation algorithm works, and you are open to go to this link, and you can see that first of all, it is going, it went from here to here, and once it have using this error function, error derivative, it has found the error, it will now propagate this error from here to okay, so it will be propagated to an input again. So go through this links at your own pace, but going back to the code again, we have input declared, we have also compiled our model. Epochs 10, what does that mean? I want my model to see each of this 60,000 images 10 times. I given just input images, I give training labels, the epochs, and I called model.fit function. And now you can see that it is printing the logs that out of the 10 epochs, uh, on the very first epoch. So when it completed the one epoch means when my model show all of the 60,000 images for the first time, what was the accuracy of that? It was learning from each of these images, and then it was calculating its accuracy on, after seeing all of these images for just one time, the accuracy was 87%. And then when it show all the images for the second time, the accuracy increased to 91. And when it went to epoch 10th, it got achieved accuracy of 93 percentage. This is not a testing accuracy, but a training accuracy only. So all of the 60,000 images which we used in a training, it was calculating its accuracy, that how I am learning on this. It is also the printing out the logs, and here you can see the train accuracy is around 93. So now we want to understand the test accuracy. So now we will not use all of the images which were part of a training as a testing. Remember in this demo, um, I give it input images here, and then on I did a live demonstration. I captured some images of me which weren't part of the training image. I had one image where my face and mask was on the very left hand side. It That image wasn't part of a training, but then I wanted to test that was my able capable enough to understand from this image or not. So that's why one should never use test images as part of a training. And we have already separated the 10,000 images on the very first line of our code, and we will be using these 10K images which weren't part of a training first of all. But now once our model has been trained on this 60,000, we want to test on this unsync data to our model on real life data, that what's the accuracy of it, and let's see what it has predicted. Test accuracy is around 92.77 percentage, which looks quite good. And then uh, let's say I gave one. Okay, um, it's okay. It's possible that I ignore to import the TF library there. So let me predict here again. Okay, so now when I give one of the test image to my model, it predicted into the class 7. So it is possible that it is like of 7. But now I want you to understand more better example, because handwritten digit recognition is not a very fancy example which all of us would be interested in knowing. So now this is another example which is of which are again of 10 classes, and there are images of shoes, of pants, of trousers, caps, and something shown here. And now we will be using a similar kind of a code which we used here in the MNIST dataset. First of all, we are just importing the TensorFlow library, importing the Matplotlib library to plot all of these images. I downloaded the Fish and MNIST dataset, splitted the dataset into two halves, one for testing and one for training. These are also labeled example. That means it's a supervised learning kind of thing. Again, there are 60,000 images in the training and 10,000 in testing. But this time, these images are of uh, clothes and shoes, trousers, etc. The way we did pre-processing of converting all of this data points from 0 to 255 to 0 to 1, we will be doing that here as well. And then this is how all of this images looks alike. Now let's develop a model. This is a deep neural network. I have This is the same line which we written in the digit recognition. We had 28 cross 28 cross pixel image as input. In the output, there are 10 classes, and to convert those into probability, we are using the softmax argument. So this line is very similar to which we have already seen, and these two are the dense layer, because as compared to digits, understanding these images a bit difficult. So now we want to create a more complex model, so that all of these yellow hidden layers which are present in this image, which are known as hidden layers, um, uh, these two lines represent those hidden layers. And 128 means there are 128 neurons out there. So all of the yellow um, dots which you show here in this diagram, there are just three, but now since there are 28 cross 28 cross image, and then I'm flattening that image, so there are in total 784 pixels in each of this image, which will go as an input. And then in next the hierarchy of this model, there is a 128 bit neuron layer. Then again there is a 128 cross length of a neuron layer, and then in the output I'm telling my model to predict uh, the probability using softmax. Now again I'm using the same Adam optimizer. So Adam optimizer works on gradient descent algorithm, which I showed you in a very quick way how you can calculate loss and do the back propagation on it. And again, I'll be training this for 10 epochs. I'm giving training images as input, training labels, and for validating that whether the model is learning or not, I'm giving test images and test labels and this epoch as an input. And here on the runtime, we can see that accuracy on the first epoch was around 82%, via in the fifth epoch, it was around 89. And you can also change this epoch 10 to 100 or 50 or whatever number you like, and rerun this model again. So it'll make your model more and more complex, and you can try. These are all hyperparameters which you can tune to your model. And after the 10th epoch, the accuracy was around 88%, the validation accuracy. And then the test accuracy was similar. And the same way you can plot the graphs, you can see here that the training and validation the blue line, I'll share this link to this collab with you all. And it is not very difficult to understand. It's a pure Python language, and using TensorFlow and Keras libraries, but and matplotlib to plot of all of these graphs. But yeah, you can see that the training accuracy is increasing epoch by epoch. Also, the loss is decreasing. It's, after the 10th epoch, the loss was around 0.3. What does that mean is accuracy is should be around 99.7%. So this is how you can visualize how your model is performing on every epoch. This was on Fashion Amnest. This model was on handwritten digits. In this code only, I have written a code how to build a convolution neural network, how to work on cat and dogs images, and all of the outputs are also present. And to make all of you understand the stuff in this notebook today will be a bit difficult, but you can reach out to me anytime on LinkedIn, on Twitter with my handler Charmi Choksi to in case of you having any doubts or question regarding this. So I'll also be sharing you the slide which has some of the links of backpropagation, how your model works, and the demos which we show in starting of this session, the teachable machine, quick draw, and some of other experiments. So yeah, I hope you guys had a feel of how the deep learning area is, what it is. It is concept heavy and code lightly feel. Just by writing 6 lines of a code, you can develop a neural network, a deep neural network, and so on. But to understand what lies beside this, behind that, to go into the research field of it, you have to be good at linear algebra, statistics, probability, calculus, and differential equation. So those are the mathematical area which I would insist you to explore if you are interested in developing such kind of applications in future. Then you have to be good at one of the programming languages such as Python or R, and then just pick up any random project, start working on it, and it'll be fun to work with work with images, with text data, with videos, and so on. So yeah, it's almost 6:12, and now I would be happy to take couple of questions you might have regarding my session or in general the field of AI. In this PPT, I have mentioned how convolution neural network works as well, but which I will be making you guys unsupervised. I will be making you guys to learn in an unsupervised fashion. I have given you resources. I will give you codes, but learn it by yourself. Learn it through other videos, or maybe reach out to me anytime, or we can conduct another session of not so beginner friendly level to go deeper and deeper into um, the slides and the codes. Yeah. So how to predict data in PDFs. So Vamshi is asking how to predict data in PDF.